Okay, folks, let's start with the binary. So, we have here the circuit for the debouncer. Here we have a counter. Here we have the binary to 7-segment decoder. Here the 7 resistors to pass to the display. Here is the bar graph, and here is the BCD-to-decimal decoder. Okay. How do we organize our wiring? First thing first, we have to organize the power supply wires. So I'm going to use the red for the positive. So here from the top, I'm going to bring anywhere where I need a positive. I'm going to bring it over here. So this way, it doesn't matter where the circuits are plugged, all of them are going to have access to plus 5 volt. In the middle of the board, I'm going to even need some jumper to pass the power on. It looks okay. So far so good. I'm going to do the same with the ground or the common. So the bottom line I'm going to use for the ground. So here your logic probe is already prepared. So anytime I'm going to need it, it's going to be ready. So I'm just connecting black wires for the ground. That's actually one of the rare situations where I'm going to maintain a kind of color code, because I'm going to need this to quickly identify where do I have access to power. So I transferred the power, ground, positive, ground, positive, ground, positive. And now I'm going to energize all the integrated circuits. So luckily, our integrated circuits are easy to use. All of them, they have the last pin in the bottom, the common or ground. So very easy then. From anywhere, I'm going to draw a wire to their ground. I'm done. So all the packages, they have the ground related. And then I'm going to relate the positive of each of them, which is the pin on the top left, on the top right. And the pin on the top right is going to be related to the closest positive line. So this way, all the packages are going to have access to plus 5 volts. Okay? I am practically done. So now all packages are energized. Okay? Then I'm going to focus on my first diagram here, which is making the debouncer for both micro switches. So for the micro switches, I put them clearly here with a label. So the label is showing the common is a blue, the white is normally open, and the green normally closed. So I did this for both of them. Both of them, they have the same wiring. So now, according to the way the gates are arranged inside the package 7400, I'm going to do one of them. So it's going to be like this. The normally open comes here on the pin 13. Normally closed come here on the pin 9. Found a broken wire somewhere, have to remove it. and the common is going to be to the closest negative line. Okay, so this one is done. Now I connected only the micro switch, but in order for the micro switch to operate, it needs two 4.7 kilo ohm resistors. So these are going to be related to the positive line. So very easy. I'm going to relate both of these legs to the closest positive line. Then I'm going to need to make the cross links the actual feedback in the RS flip-flop. So for this, I'm going to use other colors. So I'm going to use here 8, 9, 10, 11 are going to be together, and then also 8 to 12 are going to be together, okay, right here. So at this moment I've made the links around the package. So for me, in order to check, I'm going to pick up my logic probe, and I'm going to connect it to the pin 8. Don't try to connect it here in one of the holes, because the only thing you're going to do, you're going to enlarge the hole, and chances are you're still not going to touch the internal electrical contact. So better is to touch the pin of the package. So you can see here is a H from high logic or 1, and in the moment I press it, it should go to low. It doesn't. So if it doesn't, it seems that I have some troubleshooting to do, because maybe one of the links is no good. So I'm checking here, I have a high, so I identified this one here, and then I realized where was the mistake. I accidentally connected the resistor to the pin 8 instead of the pin 9. So we're going to try again. In the moment we touch the pin, it goes to low, high, press low, high, press low. And if we do exactly similar on the pin 11, on the pin 11 is right here, it should do right the opposite of it, you see? So it's working fine. If I'm using now the logic probe we're going to build later, let's see, how do we do this? We just have to energize the probe. So I'm gonna give the probe a positive and a negative, and with the remaining wire I'm going to touch, okay? So when I'm going to touch, this is my output. So you can hear the high frequency sound. When you press, the sound goes lower frequency. So 1 logic, 0 logic, 1 logic, 0 logic. The purpose is not to be too loud, because it's going to be very disturbing. So this is why it's not a very high level noise, but that's how I'm using the logic probe to figure out. So I've done one of my debouncers, this one here. Now I'm going to do the other one, and we're going to work using the same principle. I'm going to have one connection to the ground for the blue wire. The white is going to be the normally open, which is going on the pin 1 of the package. Pin 1 is on the top left, and is going to be the pin 5, the normally closed. Same thing as for the other side. I'm going to need 2 resistors, exactly where the 2 pins of the micro switch are touching. And if this one is detaching here, I'm going to stick it back, just for the sake of clarity. Okay. Second resistor, I'm going to connect it pin 1, anywhere here, and I'm going to give this line a positive 5 volts to make sure it's coming. Very good. So now, exactly like on the left side, we're going to make the cross links, the feedbacks. So we're gonna pick up similar wires. So here I'm going to have 1, 2, 3, and 4 together. We're going to have 6 and 2 together. And we're going to check if the second one is working fine. So we do the same as before. We should be able to touch the pin 6 being somewhere here. So on the pin 6 I should have a high, and then when pressing it should go low. You see, it's going low, low, high, low, high, low, high. And if I do this on the pin 3 or 4, it's going to do right the opposite of it. So it's a low, it goes high, low, high, low, high. That's how I'm checking the circuit. I can do the same with the logic probe we're going to build later on. So by connecting it or touching the connection to the pin 6, it's a high pitch. It goes lower, high, low, high, low. I remove it from here. I place it on the other side, pin 3 or 4. Low pitch, high, low, high, low. So it's working just fine. Very good. So practically both the debouncers are done. Everything is working fine. If the debouncers are gone, then I don't need any more this one here. So I'm going to focus on my project. Now I focus on my counter. I don't pass to anything else before I see my counter working fine. Okay? So for my counter to work fine, I know already that I connected the power supply on the pin 8, which was the ground, and 16 was the power supply 5 volt. To the power supply 5 volt, I'm going to link also the pin 11, because the pin 11 is called load. I don't need it right now. 9, 10, 11. This one is gonna go to any positive line. So then I'm going to connect a reset. So for the reset, I'm going to pick up here a wire on the pin 14, and I'm going to bring it over here and checking right away with my logic probe if on the pin 14 I can get the one logic I need when I press the button. So when I press this button, it's going to high, low, high, low, high. We're gonna see later on how do we use the signal. But at this moment we have the reset connected, okay? So we focus first on the control terminals. So after we connected the power supply, we connected the pin called load, pin 11, then we connected the pin 14, which is the reset. Now we focus on the 2 pins counting up or down, and this is where we built our 2 debouncers, because in order to have the counter operating fine, our 2 debouncers are going to give signals to the counter to count either up or down. So let's look for some wires to make this connection. I'm going to pick up a wire from the pin 6, and from the pin 6 I'm going to count up. It's going to be pin 1, 2, 3, 4, 5, and then I'm going to do a similar thing from the pin 8 on the pin 4 in order to count down. So we don't trust nobody, we have to check. So here what happens is on both pins you should hear a high pitch, and if you hear a high pitch is because it's a high logic. You press it, it goes low, So pulses are coming to count. Similarly, I'm going to connect it on the pin 4. It's going to be the same story. Everything is fine. I disconnect my probe. So I connected the control pins, pin 11 and pin 14. Now I connected the counting pins 4 and 5. Now I'm focusing on the outputs. Because I only want to check the counter now, I'm going to use here a group of LEDs, just light indicators. So these light indicators are going to tell me that the counter is working fine in binary. So pin 7, it goes to LED 1. Pin 6 is the next, goes to LED 2. Then pin 2 on the counter, it goes to LED 3. And pin 3 of the counter, it goes to LED 4. If the counter is operating fine, I should be able to reset. You see, all the lights are green and the green says for low. So now everything is reset. I try to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. If I press one more time, it goes back to 0. If I want to count down, from 0 it goes back to 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and 0. And of course it goes back. So we can confirm our counter is working fine. We just finished this part doubled because we have 2 debouncers, and we finished the counter. Now, easiest thing to do, if we have the counter counting in binary, why not to convert the binary counting into, or the hexadecimal counting into 7-segment display. In order for us to do this, we have to use the same outputs of the counter, and now to draw wires to the decoder. The decoder is right here. It's very close. So we're going to try to use the same colors as before. So let me see, LED 1, we connected a white wire. So we're going to look for a white, just for clarity. So from this pin number 7 of the counter, you should go to the pin number 6 of the decoder, okay? Right here. Next, pin 6 of the counter. Let me see what did we connect over it. It was a red wire. So we pick up a red wire. So pin 6 of the counter. This was 7, 6 of the counter. Okay. It's gonna go in the top of it on the pin 2 of the decoder. Is over here. Like that. Next, I used a yellow wire, so I pick up a yellow, and now the yellow is going to be connected between pin 2 of the counter, so pin 2 of the counter over here, and is going to the pin 1 of the decoder. Pin 1 of the decoder is right here. And finally, the pin 3 was a green wire, so the pin 3 of the counter was a green wire, and is going to be connected to the pin 7 of the decoder. Okay. Pin 7 somewhere here. So now the counter to the decoder is connected. I can still count in my binary over here. Everything is going fine. 4, 5, 6, 7, 8. So it's counting fine. And now the decoder cannot be connected directly over the 7-segment displays. We have to protect the LEDs by inserting resistors. So for these resistors, we have now 7 wires to connect. So the outputs of the 7447, which is a decoder, we have them in order: pins 13, 12, 11, 10, 9, and then 15, 14. So we go here on this side, and we have 9, 10, 11, 12, 13. In order for it to work, we're going to connect it like that to one side of the resistors. So 12 is here, and then we're going to pick up the 11. I tried to use different colors. 9 to the next, okay, and 15 and 14, okay, sorry, 9 is here, okay, now 15 is the next, and last one is gonna be 14. 14 is right here, that's it, to the last resistor, which is over here. Let me see if there are any mistakes gone. Everything looks fine. And now from the other side of the resistors, we're going to connect the digit. Now for the digit though, we have the pin out right here. We're going to use these ones because the decoder is a special type common anode. So the digit is also common anode, meaning the pin 3 or the pin 8 or both have to be related to the positive. So that's what I'm going to do. I prepared the wires already. I'm going to connect them to the end. I just don't want to forget some control terminals of the decoder. They have to be connected to positive, the pins 3, 4, and 5. And we do this right now. So the pin 3 to 4, 4 to 5, and from any of them, if I pick up a wire from any, I connect it to the closest positive line, and that's it. So now we focus on the digit. So the digit has the pinouts like this. If you take a look, it's going to be like you arrange the digit, seeing the decimal point or the dot to your bottom right, and here is going to be the pin number 1, okay? So if I put it like that, it's going to be exactly like my digit is arranged right now. So for me, I have to figure the pins of the decoder representing the 7 segments A, B, C, D, E, F, and G to go exactly to the same segments over the digit. So the one coming from the pin 13, it was the first resistor here. We're going to use the same color as we connected already. So it was a black. We pick up the black from here. And this is going to go to the segment A, which is on the pin 7. Pin 7 is the second from the top, right here. Next is going to be the segment B from the pin 12 to the pin 6. So next color I used was the white. So we pick up the next one, which was the white, and it's going to the next one, which is the pin 6, is right here close to 7. Okay. Next one, it was the segment C, and the segment C from the end of the resistor has to reach the pin 4. What color did I use for that? It was, if I can see well, it was a blue. So we pick up a blue from here, and the blue goes on the pin 4, which is next to 3. Very good. Next, the segment D is from 10 through the resistor and reaching the pin 2. So this is the D. So it was the 4th color here. So after the blue, it was a kind of orange, So I pick up the orange from here, and orange is the next one, and it's going to the pin 2. Pin 2 is on the other side of the pin 3. This was the D. Now E is going from the pin 9 and is reaching the pin 1. So the next after the orange here, after the orange was a red. So we pick up a red from here, and from the red we go to the pin 1, which is right the next on the pin 2. Now pin 15 was going the segment F. The segment F is on the pin 9. So the segment F is a yellow wire. The yellow comes right here, and it goes to the pin 9, which is right here after. I'm gonna pick up another one that's defective. Okay, so from here we go to the pin 9, which is right next to 8, and finally we have the green. Don't have to look anymore, is on the pin 10 over here. Okay? In that moment I'm going to relate one or both pins. I'm going to relate both, is a more reliable link. And now whatever I see here, 1000 in binary, is representing the number 8. Let's count from 8. I reset, you see, 0 here, 0 here. I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Remember, the 10 is represented by a symbol. I'm gonna bring it here back to you. Okay, so we're going to put it in the same position so you can see on the digit. This is 10, this is 11, this is 12, this is 13, this is 14, blank display is 15. If I press it one more time, it goes back to 0. So what did we do? At this point, we wired the two debouncers, the counter, the binary to 7-segment display decoder, and now what's remaining? The BCD to decimal decoder. Okay? So from the counter or from the decoder, we're going to take 4 wires to bring them to the decoder. Okay? So to bring them to the decoder, we're going to use from the pin 7 of the counter. If you take a look, you should go to the pin 12. Okay? So pin 7 of the counter, pin 12 is 9, 10, 11, 12. Okay? One is done. Pin 6 of the counter goes to the pin 13. Pin 6 of the counter, let me see, right here, it goes to the pin 13. 13 is next to 12. Pin 2 of the counter goes to the pin 14. Pin 2 of the counter, pin 2 of the counter, let me see, is over here, goes to the pin 14, which is next one, and pin 3 of the counter to the pin 15. Pin 3 of the counter, pin 3 of the counter to the pin 15. So obviously during all this time nothing changed yet, so my counter is just working fine. I have 4, 5, 6, if I count backwards, 5, 4, 3, 2, 1, 0, and back to 15 where the display is blank. What's remaining is now to make the links between the outputs of the decoder to the bar graph. So the outputs of the decoder to the bar graph, what we're going to do is to consider all the pins 1, 2, 3, and so on. So the first one we want to wire is going to be in the bottom here. So we're going to pick up some wires, trying to do these things. So let's say from the pin 1 of the decoder, right here, is going to be the first LED right here in the bottom. Okay. Next, pin 2 of the decoder. Pin 2 of the decoder is going to be the next LED right here. Pin 3 of the decoder is going to the next LED, which is right here. Pin 4 of the decoder, 1, 2, 3, 4, is just the next one, is going to be the next LED over here. Pin 5 of the decoder, is going to be on the next LED, right here. Okay. Pin 6 of the decoder, is going to be on the next LED over here. Pin 7 of the decoder. Pin 7 of the decoder is going to be on the next LED over here. We cannot connect the pin 8 of the decoder because this is the ground, so we go on the pin 9 of the decoder. Pin 9 of the decoder, which is on the other side, right here, and it's gonna go over the next light. Okay, and we still have 2 to do. Pin 10 of the decoder, pin 10 of the decoder, from here to the next light, and one more remaining. Pin 11 of the decoder, there is just one hole which is not used, to the first light in the top. Okay, very good. So now links are done. In that moment, I can simply check my circuit. I cannot see any light here, I cannot see any light there, but I see here 1111, which is 15. This is why the display is black. If I just give it one pulse to go to 0, hey, not only it goes to 0, but the first LED here on my bar graph goes on. If I continue, it's going to advance one position at a time. 3, 4, 5, 6, 7, 8, 9. And if I press it one more time, the number goes above 9, which is 10, and this is why the decoder, because it's called BCD, which is equivalent to decimal numbers, the decoder doesn't recognize numbers bigger than 9, so until I go back to 0, 14, 15, the decoder won't work. And now it's going to work again. So we wired the circuit completely. Our circuit is just fine. We used the logic probe only when required for checking purposes, and I told you already that if we follow the wiring right away, step by step, dividing or splitting the diagram in smaller stages, practically the troubleshooting is done at the same time with the wiring. Okay? Another nice thing I can show you is that the bar graph is a bicolor one. So if I just connect the resistors, instead of being grounded, I connect them to the positive, and I reverse the bar graph, then you're going to see something very interesting. Instead of having only one light going on and the others off, all the lights are going to stay on, and the selected one, like now is the light number 5, only this is going to go off. And additionally, because it's a bicolor display, the color is going to shift from green to red. So if we just connect it here and we connect this to the ground, okay, now we can use the same green, and as you can see now is the number 5 going like this. So all the lights are on as soon as the display is showing 10, remember. I'm putting it here, exactly the same position. This is representing 10, 11, 12, 13, 14, 15. And now again, only one light is on. Or if I leave the display as it was originally connected, you're going to see exactly the same story, excepting the lights are red instead of being green because it's a bicolor, okay? So take a look. 15, and now again 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And if I connect it back from here to the positive, it's gonna be like before, one light at a time. Isn't that nice? So what did we do? We prepared our diagram, which is containing 2 decoders, a counter, 7-segment display, and the bar graph, and of course the 2 debouncers. We have them ready when I'm going to present you the logic probes. Then we can take measurements exactly based on that circuit. Thank you very much, guys. See you for the logic probes. Bye-bye.